Hello everyone! In this video we are going to go over how to model a spring mass damper system in Simulink. So here's the problem statement. Consider a spring mass damper system with the following mechanical properties displayed in Table 1 on the next slide, and construct a Simulink model of the system and generate a graph of the system output. So real quick, here is the equation of motion for the mechanical system. The equation of motion is m times x double dot plus c times x dot plus k times x equals f of t. In this case, f of t equals 0. Here's the data table for the problem. So for this problem, our mass, m, has a value of 12. Our dampen coefficient, which is c, has a value of 53. And our stiffness, k, has a value of 96. We also have an initial displacement of 0.005 and an initial velocity of 0.001. Here is the updated equation of motion with our coefficient values. Now, using that equation, the next step that you can do is calculate the transfer function. We will use this transfer function in a later video going over an alternate approach for modeling a spring mass damper system. And now on to Simulink. For the actual model, the model we're going to create is going to look like this. Now, the first thing you're going to want to do when you open Simulink is create a new model, which I've already done. But if you want to do it, you can click right up here and click this add block, and it will create a new model that will look like this. Now, the first thing we're going to want to do is specify our input block. So our input block is going to be a sine wave input and look something like this. Now, the next block we're going to want to add is going to be our loop block, which is essentially an add block that represents the complete loop. So we're going to add the add block, and I'm going to title this one loop, just so we can see that this is our loop add block or loop block. And in order to make a complete loop, we gotta subtract our gains from our inputs. So we're going to change that bottom add to a subtract, which makes it a subtract block. And then we're going to add our gains. So because we have 3 coefficients in our derivative, we need 3 gain blocks, 1 for each coefficient. The first one is our mass. And in our original equation, our mass was 12. But we're going to normalize it, and it's going to be 1 over 12,000. Now, our second gain block is going to be our damping. And this block has a value of 53. And our third gain is our stiffness. And our stiffness value is 96. Now, as you can see here, we have our 3 gain blocks. The next thing we're going to want is we are going to want our integrator blocks. And we're going to want 1 integrator block for each of our gains. So the next thing we're going to add is our integrator block. Next, we're going to add our outputs. So we're going to have two different types of outputs in this model. One is our scope block, and we're going to have 3 of those. One for position, one for velocity, and one for acceleration. I'm going to reorganize these blocks a little bit. Now, the last block that we need one more add block. And I did say that we were going to have 2 different types of outputs. So the second type is going to be a 2 workspace output, which is going to be taking our position data and sending it to MATLAB for post-processing. Now that we have all of our blocks, all we have to do is connect them. So we're going to connect our loop block to our mass, and our mass to our first integrator block, and then our first integrator block to our second integrator block, and then this block is going to be connected to both our position block and our SimOut block. Before we add our position data back in, we're going to pass it through this gain block of 96. And we're going to do the same thing with our velocity data, which is this line right here. And we're going to connect this to our damping gain and connect this to the add block here. And then we'll just connect this add block to the bottom of our loop here. Our input will go to the top of our loop block. And now all that's left to do is connect our velocity and our acceleration blocks, which go to our data strings for acceleration and velocity. Now in this model, we haven't added the initial conditions yet. So to add those, we are going to click on the integrator blocks. And we're going to, where it says initial condition, add our initial conditions. So for the first integrator block, that is the one that gets us our velocity data, we are going to set our initial condition to 0.001. And for the second one, we're going to set our initial condition to 0.005. And now if we rerun it, you'll see that our data has been optimized and it starts from an initial position of 0.005. And our velocity, that's this guy, starts from an initial value of 0.001. Now, the last thing we're going to do in this video is I'm going to show you how to add labels to your scope block and save your scope block as a figure. So, adding labels to a scope block is really easy. All you're going to do is go in and you're going to click Configuration Properties. It's going to bring up a menu that looks like this. You're going to go to the x-axis, which is time, and you're going to show the time axis label. And you're going to add seconds because time is, in this case, evaluated in seconds. Now, the next thing you're going to do is you're going to go back into that Configuration Properties menu, and then you're going to go over to Display, and you can add a Y label. And we're going to say position in meters. Now, the last thing we need to do is add a title. We're going to go back into Configuration Properties, and we are going to go in here. We're going to go to where it says Display Title, and we're going to say position versus time. And if you want to add a legend, all you have to do is click Legend, and it will add one. In this case, it's using the title Integrator 1. If you want to change that, all you have to do is click on the integrator block associated with the data and rename it Position Data. And now, as you can see, it has updated the legend accordingly. So if you want to save this, all you have to do is click Print to Figure, and it will generate a figure that will look something like this, which you can then save onto your computer. Now, really quick, I want to show you where this out.sim out saves to. So if I go into my MATLAB window, you'll see a variable pop up that says out. So this is where that simulation data, that position data, is being saved. So if you click on it, you'll have a bunch of different variables that pop up. Simtout, which is right here, is storing the time data. And if you click the out.sim out, you can see that time data that we had from before with our new data recorded from the simulation. And that's all. So that is how to create a general model of a spring mass damper system in Simulink. Thank you for watching.